Okay, tonight we're going to do lesson 15, apply estimation to real-world situations by using rounding. Now this one is going to be a little tricky because we're going to be breaking some rules about always looking for that magic number 5 to the right of a number in order to round up. Anything less than 5, we round down. You've always been taught that, and it still holds true, but not in real-world situations. In real-life situations, if you're planning on a party, and you have 43 people coming, are you going to round down and only have 40 things for the party, or are you going to round up to make sure everybody gets something at the party? So it's very important to remember when it comes to estimation, we're not always going to follow those rounding rules. So let's get started. Mia's aunt wants to buy 3 items at the store. The prices of these items are $21, $44, and $62. Mia estimates the costs of the 3 items. Then Mia's aunt takes $120 to the store to purchase the 3 items. So you got to make sure that you're going to have enough money to go to the store with. So what you see here are called vertical number lines. You've seen these before. And I am going to set it up. Since it's $21, my first notch is going to be 20. Then that halfway, remember it's always the 5, is 25, and then it gets rounded up to 30. Where is 21? Well, the 21 is about here. Okay, all right. So I would say 21, is it closer to 20 or is it closer to 30? We would say this one is definitely closer to 20. The next one, 44, we have started with 40, we have 45, and then we go up to the next 10, which is 50. Where is 44 on this number line? Well, it's very close to 45, so it goes there. How would you say? This one gets rounded to 40 because it's less than 45. Then we have $62. Well, we go to 60. That halfway point is 65. And then we jump all the way to the next 10, which is 70. All right. So $62 is a little bit less there, so it's going to be rounded to $60. So let's see if she has enough. So we've got 20 plus 40 is 60. 60 plus 60 is 120. So she does have enough. If we focus on this problem, did rounding to the nearest 10 help Mia accurately determine how much money her aunt needed to purchase the items? Definitely not. Her aunt maybe needs $7 more. Mia's estimated too low because all the prices were higher than the rounded numbers. There's also the consider tax that the store puts on items when you purchase them. Mia rounded each price to the nearest 10, but that did not help her determine how much money her aunt needed to take to the store. How does this change the way you think about estimating? Well, it makes me think that sometimes rounding could tell us the wrong information. It makes me think that there have been another way for Mia to think about this problem. Again, because there's certain things that you don't think about when you're going to go to the store. There's tax. Items could have cost more. So this is clearly a way, perfect example, that just going about the rounding rules does not apply in this real-life situation. Okay, so let's think about how Mia could do this differently for this real-life situation. Because we don't know exactly, is she exactly sure those items cost that exact amount of money, and then she has to also think about tax added on. It's always good to have a little bit more than less. So let's see, $21, again, that we are going to be placing closer to the 20. And this one gets rounded to 20. Okay, and then we have 44, and we said that's very close to 45. And then we have $62, which is closer to 60. All right, so these are more accurate. The one that I felt that wasn't going to be good was the $44 one, because that is very close to the 45. And if it was very close to 45, that means that we would round to 50. So we would want to make $44 really into $50. Again, because you're dealing with money also, when you go to the store, you want to have a little bit more to cover those extra charges. So let's say if we now added this all up, we have 20 plus 50 is 70, and then 60 plus 70 is $130. So this would be the safer amount to bring to the store for Mia's aunt. Miss Wong needs to set up chairs in rows of 10 for 123 people. She rounds 123 to estimate how many rows she needs. So let's give this a try. So if I put 123 down here, here's 123 here, I would say then she was closer to 100. 123 would get rounded to 100. Would that make sense? No, that would not make sense, because this is, there would be fewer chairs for people to sit on. You won't have enough chairs. So that first estimation would not be correct. What about the second one? Let's say if we put this again, 123 on this vertical number line, and then, let's say we shoot up to 200. We are going to have too many extra chairs. We would have 77 extra chairs. That's just too much. Now let's try another one. Let's say, okay, we put 123 here, and then we're only going to round to the nearest, the tens. Instead of the hundreds, we're going to go to the tens. Would we have enough? Would we have enough people, enough chairs? If we jumped all the way to 130, yes, we would have 7 chairs left over. And that's fine. It's always good to have a little bit more than less. 77 was way too many extra chairs. Too much work to be putting it out. And who even knows if she's going to be charged each chair? 7 extra chairs is definitely a good number. So again, this is a perfect example that basic rounding rules did not apply. Okay, let's always believe in yourself. Try your best on the next 2 problems. Jenny's pool holds 7,326 gallons of water. Jenny's father rounds to the nearest 1,000. Jenny's mother rounds to the nearest 100. Who is correct in order to make sure that you are going to get a reasonable amount of water into that pool, and you're not going too high and you're not going too low? Krista needs to order 1,153 lollipops for the block party. Should she round to the thousands or the hundreds? Remember, you don't want to have too much and too less, especially if everyone wants to get a lollipop. Believing in yourself is the secret to success. Have a wonderful night.